Now it's time to learn more about networks. Now what I can do is I can take a letter and I can stick it in an envelope. And when I stick it in an envelope, what I need to do is write an address on the front of that envelope. I am addressing a certain location. I want this letter to be addressed to a certain location. And likewise, we use it in the English language. If I say I'm talking to you, I could say I am addressing you or addressing a group of people. So that's what we mean by address. Address just means target. It's a targeting system. And likewise, on the reverse, I can provide my address on that envelope. So when I post it, that individual that receives the letter at that location, at that address that is being targeted, they can flip it over and they can look at where the letter came from. And then they can write a letter, put it in an envelope, and write my address. So now not only can I send, but I can also receive, and that's vital for networking. Networking goes both ways, just like letters in the mail. So now that we know addresses are here for targeting, and in order for our computers to do this, we need something called IP addresses, which stand for Internet Protocol Addresses, or a targeting system for our computers to communicate over the global network. That's what IP addresses are for. We have the internet, which is all of these computers connected together, and the internet needs a protocol, a system in which we can target each computer, and we do that via addresses. Addresses are there for targeting locations, and of course, what it means in computer terms is targeting computers on a network. Now, what do we mean by IPv4 and v6? Well, the V stands for version. Just like when you have your software and you update it from version 1 to version 2, well, the Internet Protocol has been updated and it has received revisions. Now, the first major revision is version 4, IPv4, which is currently in use today by pretty much all of your devices. And IPv6 was created later on because of the sheer amount of devices we have connecting to the global internet. But we'll talk more about that later. For right now, I want to talk about IPv4. So let's take a look at a standard IP address. And what you'll notice is it consists of 4 bytes. Or some people like to say 4 octets. But what is an octet? An octet just means a grouping of 8. So if there was 8 people together, that would be an octet of people. So whether you want to say 1 octet or 1 byte is entirely up to you. They mean exactly the same thing. An octet in computing is a group of 8 bits, just like a byte. So it's entirely up to you what you want to say, but please don't get confused. So we now have 4 bytes. Now, these bytes consist of 8 bits. And we know that we have an unsigned number range of 0 to 255. This is the first point. IP addresses aren't negative. There's no such thing as a negative IP address. There's no need. So we are working with an unsigned bit system. Now, number 2, we have 4 bytes here. Each byte can go from 0 to 255. Now, when you look at your IP address, what you'll notice is it's separated by dots. So for example, my IP address could be 192.168.0.2. Now you'll notice this IP address is consisting of base 10 numbers. So your computer does not understand base 10 numbers, it only understands base 2 numbers. So what you need to do is you need to convert those base 10 numbers to base 2 numbers. So convert 192 into its binary representation, and so on and so forth for all the numbers. And eventually you're left with 4 bytes. Now please understand, visually they look like separate numbers, 192.168.0.2. They all look like separate numbers. They are not. They're just for us to remember our IP address if somebody asks us for an IP address so that they can connect to our computer. However, our IP addresses are in fact one long 32-bit base 2 binary number, because once you have the binary representation, just simply take out the dots and whatnot and just stick them all together and you end up with 32 bits. You went from 8, 16, 24 to 32 bits. And those 32 bits, make up a number, and that number is your address. It allows people to target your computer specifically. So where does this IP address come from? This IP address comes from your internet service provider, being either Virgin Media, Sky, Verizon, AT&T, whoever they are ISPs, internet service providers. And this service provider will of course give you the infrastructure to send your bits and bytes over the network, but it also gives you the IP address. That allows you to be addressed on the global Internet of Things. But this presents a whole nother problem, because we are working with 32 bits. That's IPv4. 32 bits has approximately 4 billion addresses. 4 billion possible 1 and 0 combinations or base 2 numbers, which means we have approximately 4 billion addresses. However, when you consider the population of the world is nearly double that, and the fact that a single individual now owns a smart meter, they own a laptop computer, maybe several computers, smartphones and tablets that can all connect to the internet, and each one of those has to have an IP address to be identified. So when considering that, 4 billion isn't enough. So how did we actually solve this problem? Well, we solved it with routers, and if you have a look at the box that your router came in, you will find NAT, N-A-T in capital letters, and that is Network Access Translation. That's what it stands for. And what does Network Access Translation do? Well, it limits the amount of IP addresses that the ISP has to give out. Your router is the bit that connects to the ISP, and the ISP, the Internet Service Provider, gives out 1 address. That's the goal. They don't want to give out 4 addresses for 4 devices, because then they lose 4 addresses. And if eventually everybody starts connecting, there's some people that are going to get kicked off because they physically have no more addresses left. And that's a big no-no. So the ISP wants to limit the amount of addresses it gives out, because once it gives out that address is allocated, it's given to a device. They cannot use it until that device disconnects. So what you have is a router, and a router connects to your ISP, and that router is a computer, so it needs an IP address. Now this IP address came from the ISP. This is the only IP address you receive. And this is called a public IP address. Anybody from the public can actually access that IP address. Now behind that you have your individual computers on the network. These have private IP addresses. Now these addresses didn't come from the ISP. These addresses are allocated by your router. So let's say, for example, I have a laptop, a smartphone, and a tablet device that connect to the router. Each one of those devices will be assigned an IP address from the router, not from the ISP. So the ISP doesn't lose any more addresses. It's only given out 1 address, and these private addresses are provided by our router. And then let's say I log on to my laptop computer and I open up a web browser. Now, whenever you type in an address such as google.com, what it's doing is it's actually requesting data from a server, and that server has an IP address. Now, we'll talk more about servers and their IP addresses later on. However, what we're going to do now is we're going to send a request. How do you do that? Well, in order for you to send a request through the mail, you first have to write to the individual and say, look, give me some data back. So what happens is when you request a website, a package is made. Now, whenever you send binary data, it's sent in packets over the network. So that's what a packet is. It's just a load of base 2 binary numbers. You group them together and you send that off in a package, just like you would do with the mail. You will put something in a package and send it to wherever you wanted it to go. And likewise, what we're doing is we are requesting some information back. So that's what we're going to do. We're going to say, please give us the web page that we want. So that's going to get packaged up. We're going to write the address to Google right on the package, and it's going to go to the router. Now, the router knows the private IP address. This private IP address goes no further. The router stores the IP address, not the ISP. The ISP doesn't care about that. So the router remembers the IP address, and it sends that packet off into the Internet of Things. It sends it to the ISP and that routes it, and then eventually you will get some data back. And it knows where to send the data. The Google server knows where to send the data because your router has a public IP address, and that server, Google, can in fact see that IP address. So it sends it back again. So that's the return address. It gives us back the package. The ISP will send that package back right to our router, and now our router remembers the private IP address that made the initial request. And it says, okay, this guy, the laptop, he's the one that actually requested the data. So what it does is it takes that package and it says, right, throw it to the laptop. It doesn't give it to all the devices. It only routes it. It only routes it back to the device that made the initial request. So by having private IP addresses, it prevents the ISP from releasing all of these different IP addresses, and that will stop people from connecting. So that is why we have routers, and that's why they have NAT on the box, Network Access Translation, allowing it to route the packets, the data back to the specific device. Now, in lieu of that fact, what happens when we disconnect our router? Sometimes you'll turn your router off, and then when you reconnect it, your IP address will change. Why is that? Well, when you consider that these addresses are like money to the ISP wants as many addresses as it can. If that address isn't in use, it needs it back so that somebody else can have that address. I mean, for example, if you look at all the routers that have been thrown away in the world, well, if every router was assigned an IP address and that's it, and we throw that router away, that's one address that's been lost. So that can't happen because we'd very quickly run out of addresses and nobody would be able to throw away their router. Very, very bad. So in lieu of that fact, when you disconnect your router, the ISP knows and it goes, wait a minute. This address isn't being used. One of my other customers can use this address. So it takes back that IP address. Whilst your router is offline, it takes back that IP address and it may be allocated to somebody else. Then when you reconnect, the ISP will go, they're back online. Now take one of the free addresses and assign it back to this individual that's just reconnected. And therefore, when you switch your router off and then when you switch it back on again, you will actually get a different IP address allocated to your router. So you have public and private IP addresses. The public IP address comes from the ISP. Private IP addresses come from the router. And the job of the router is to route those public packets, that public data that came from the server back to the original computer that made the request, to the private IP. And that's what your router is doing. Now, why was IPv6 created? Well, eventually, if your population gets so big and every household and business will have a router, for example, eventually you are going to run out with the amount of people now that are coming online. Eventually, you will run out. So, in lieu of that fact, IPv6, an updated version of the IP protocol, was created, and most devices today support IPv6. There are some older devices that don't, but very rare nowadays. And every computer that you buy and every smartphone that you buy supports IPv6. What is IPv6? Well, this version of the Internet Protocol, an updated version, allows for more public addresses to the point where it would literally be impossible to run out of addresses. Because IPv6 works with 128 bits, which means that with this significant amount going from 32 to 128 bits, 128 bits will allow for, roughly speaking, 340 trillion base 2 numbers or IP addresses. we would never run out of public addresses. It would simplify things greatly, and we wouldn't need NAT, or Network Access Translation, in order for our ISPs to provide addresses for all of these different devices. We literally wouldn't run out of addresses. Addressing the problem. So, that is why IPv6 was created, and hopefully now you understand that IPv4 was the first major release and it's 32-bit, IPv6 128-bit. You understand public and private IPs. You understand NAT and how network access translation is used by a router to route packets that have been received via the public IP address to the private IP address, aka translating the public to private. And when we consider the fact that a packet is just binary data that's being sent over the network.